This is a low-profile, portable rock washer. It uses a 4-nozzle spray head, a 55-gallon drum, and a V-groove wheel to hold the drum in place. It has 2 handlebars, 2 idle wheels, and 2 drive wheels. It uses an electric motor with a reduction gear. And the drum sets at 10 degrees horizontally. For this yard project, the landscape rocks were removed from the yard and placed in a pile. A trommel was used to separate the dirt from the rocks. It took around 2 hours to wash this pile of rocks. The rocks will contain leaves, twigs, roots, and clumps of dirt. To speed up the washing process, the rocks are soaked with water prior to washing. This loosens the dirt from the rocks and softens the lumps of dirt. To simplify switching out the tubs, we use 2 tubs placed end to end. While holding on to both tubs, we could slide out the full tub and bring in the empty tub in one step. The drum is rotating around 20 RPM. The pressure washer fills the drum with water. The rocks are loaded in the rear. They tumble in the bath water. The water drains at the back, and the clean rocks are ejected out the front. The key design feature is the drum will retain and wash this set amount of rocks indefinitely. That is, the clean rocks only exit the drum when more rocks are loaded into the drum. The cleaning process can be monitored by watching how clean the drain water is. This is a snapshot of rocks just fresh out of the wash. The leaves typically don't survive the wash. The branches and roots will come out of the wash nice and clean, and the sod clumps will typically dissolve in the wash. I used the same tools as in the trommel build. And I also used a pipe wrench and tin shears for the rock washer build. This rock washer design has 6 contact points between the rotating drum and the frame. It has 2 drive wheels. It has 1 loading chute. It has 2 idle wheels, and 1 V-groove wheel. This is the design for the rock washer. You'll notice that the idle wheel and drive wheel assembly is the same as in the rock trommel. The rock washer build is the same as the rock trommel build. We start with the fixture to build the idle wheel and drive wheel assembly. And then we attach it directly to the sheet of plywood which makes up the frame. We attach the aluminum braces and attach the drive wheel and idle wheels. The V-groove wheel is mounted using a 1/2 inch threaded rod that is 12 inches long. There are 2 hex nuts to hold the 1/2 inch threaded rod in place. There are 2 hex nuts used to center the V-groove wheel to the drum. The plastic guard shields the wheel from debris falling from the drum on top of it. Next step is to cut this assembly's 2x4 to the proper length. We're using this 2x4 as a straight edge to mark our cut on this 2x4. Once the cut is made, there are 3 contact points to the ground on both sides to support the frame. The next step is to cut a 9-inch diameter hole at the bottom of the barrel. We first start by placing the barrel on the frame and allow the electric motor to rotate the barrel. As the barrel rotates, we can place a pencil against the bottom of the barrel and rest it onto the frame. This will hold the pencil still while it draws a perfect circle. This barrel is 1.5 millimeters thick and it's very tough steel. So first I had to cut a hole big enough so I could start cutting using the tin shears. I did this by drilling holes with a drill, and each time I would complete the circle I would increase the drill bit size and repeat the drilling process until the center piece came out. And that was enough room for my tin shears so I could start cutting the center of the hole out. Once that's complete, you'll have very sharp metal filings on the inside of the hole, and this needs to be filed down like is shown here. One 1/2 inch diameter drain holes are placed on one side of the drum. Before we begin washing rocks, we'll fill the drum full of water. We'll do this by rotating the drum until the drain holes are above the water line, as shown here. The goal is to have enough drain holes at the back of the drum to prevent the water from overflowing out the front of the drum while the drum rotates at 20 RPM. If you have drilled too many holes, you can simply cover them up with duct tape. If the holes become clogged, you can blow them out with a pressure washer. The final step of the frame build is to attach the chute, which we use to load the rocks in the back of the drum. This was an iterative process of slowly removing material from the 2x4s, constantly using a straight edge which we use to mark the angle, and then we'd place guides on the 2x4, and the guide was used for the skill saw so we could cut the edge at an angle. We used a stovepipe, and what I did was I stuck the stovepipe into the back of the drum and then marked off where I wanted to cut the stovepipe with duct tape. I have 2 screws on both sides to secure the chute in place, and then I have a 2x4 in the back and another piece of wood up front to support it. The first attempt to install the chute wasn't good enough. There was too much of a gap between the chute and the drum. The chute needs to ride right on the edge of the drum. What will happen is rocks of this size or smaller will roll out of the drum, and typically it will interfere with the V-groove wheel. The wire screen inside of the drum is similar to the rock trommel. You have a solid bike rim in the front of the drum, and then inside of the drum you have 8 pieces that are cut from a second rim. By having individual pieces provides a gap where the water can wash the dirt from the rocks to the back of the drum where the holes allow the water to escape. This image illustrates the 8 pieces of the bike rim, and at the very bottom is a full bike rim. Out of the box, the bike rim will not fit within the drum. It needs to be notched. I used the miter saw to make the cut, and a little bit of oil at the cut site to lubricate the carbide saw blade. This is how much material was removed, and if you include the width of the saw blade, it's about a 1/2 inch of material. These straps are holding the rim together so it easily slips inside of the drum. And this is when I'm cutting the 8 pieces out of the second bicycle rim. To build the inside of the drum was the same as building the rock trommel drum. In fact, I used the rock trommel frame for this particular build. I also used full bicycle rim temporarily, so the assembly process was easier. Inside, I used old landscape edging to create a corkscrew. This would be at the back of the barrel, and then the key feature is to stop the corkscrew before it reaches the end. This is the landscape material that I used. I used only a piece of the landscape material, as shown here. This is when I remove the temporary bicycle rim using a hacksaw blade. By placing the hacksaw blade between the screen and the rim, it was pretty simple to cut the nylon straps. Here I'm attaching the 8 pieces of bicycle rim. And then this is the final assembly. To simplify the assembly process, I only use 1 bolt to secure the trommel to the drum. This may make it easy to assemble, but if the trommel is not built strong enough, the weight of the rocks in the bottom of the drum will cause the trommel to twist apart. This is the pressure washer spray head. It has 4 nozzles, and it's rated for 4,000 psi. I'm using a 2800 psi 2.4 gallons per minute pressure washer along with a quick connect pivoting couple to drive the water broom, which is rated at 4,000 psi. The 4 spray nozzles are spaced 4 inches apart. The optimum spray area is about 3.5 inches from the base. The spray head is attached to a 1/2 inch galvanized pipe assembly. The blue rectangles represents 1/2 inch diameter galvanized pipe. I purchased the pipe at Home Depot. The 5 inch, the 16 inch, and 27 inch were cut from a 48 inch pipe. They were cut and threaded at no additional charge. The 1.5 and 6 inch pipes were in stock. After assembling the pipes together, the spray head was fastened using pipe clamps. This is an illustration of the drum. In the rock line is a representation of where the rocks will lie at the bottom of the drum. The goal is to position the spray head in an optimal position where you have both pressure and coverage of the spray nozzles. 2 pipe straps were used to fasten the pipe assembly to the frame. The drum rotation was sped up from 10 RPMs as shown on the left side to 20 RPMs as shown on the right side. Speeding up the drum helped to break up the clumps of dirt. Other than that, I didn't notice any significant improvement in reducing the wash time. Increasing the water volume flow rate would also help wash the rocks faster. The idle wheels were beefed up to support the weight of the drum, rocks, and water. I replaced it with a 3/4 inch shaft, flange bearings, and I used the same type of wheel as the drive wheels. So I started with a brand new 2x4. I made my 55-degree angle cut, and then I picked a center location for the shaft hole. So this is a 3/4 inch pilot hole that I set the shaft in and then laid down the flange bearing so I could drill the mounting bolts pilot holes. Then I drilled a 1-inch hole to provide clearance for the 3/4 inch shaft. I used a carriage bolt to mount the flange bearing. Then I used a 3/4 inch washer as a spacer for the wheel, and then secured it with a shaft collar. After an hour of continuous operation, the belt would heat up and stretch out. I toyed with the idea of installing an idle wheel to hold the belt tight, but I instead decided to use a number 40 chain. This is the trommel part of the drum, and this is what it looks like after 6 hours of operation. The hardware cloth is made up of 20 gauge steel wire with 1/2 inch square holes. The bottom of the trommel bear the most weight from the rocks. This portion had to be reinforced just to complete the 6 hours of operation. My second attempt was to place a 12.5 gauge fence wire with 2x4 spacing as a frame, and then overlay that with the 20 gauge hardware cloth, 1/2 inch spacing. This is what the trommel looks like after 2 hours of operation. It shows little wear. Thank you for watching.